Hello, everyone. Welcome to the binary episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we have a follow-up by Project Zero to the forced entry exploit chain by NSO Group, some kernel bugs and NetFilter tables, and a bit of a cool research post by Microsoft on a new type of exploit primitive they were exploring. As always, though, before we get into any of that, we'll cover the Spot the Vuln, which I'll let Z jump into.
In this week's Spot the Vuln was already spoiled for you if you listened to our Bounty episode, as this came pretty much directly out of the PHP pair topic, and one of the issues there. Uh, but kind of diving into it, the core issue, at least the one that I want to call out here, there are some other things that can be mentioned about this code, is in this reset password method. So what's going on is this function's called when users try to reset their password. They provide their new password, and then the email gets sent out using this random salt that's generated. That email and that link goes out to the user to click to verify their password change. So it is a little bit backwards. I did see somebody mention that on Discord. It is a little bit backwards from how that would normally be implemented, where you would click the link and then change the password. This is kind of having the password done first and you just click the link to verify. But the issue comes down to the salt being generated. MD5 with empty rand between. So a random number between 4 and 13. Concatenate with the user, the time in seconds, and the password itself. So the user and the password, the attacker obviously knows. Time can be pretty easily figured out, especially they call out the date header exists, which can be used to get the server's time. So really the only bits of randomness in there is that random number between 4 and 13. And this is all being hashed together, but effectively they had it down within about 50 guesses they would be able to get at any time. And that takes into account a little bit of time skew to be able to predict that and change anyone's password, getting access to any of the accounts.
I don't know if I'll ever get over that random number between 4 and 13 thing.
I mean, did they choose
Pick
their
numbers out
random
of the hat. I
numbers
don't know.
with another random number generator?
It's an interesting question. I don't know.
Yeah, I mean, it's a weird choice. It's a weird structure for the code on a whole, but 4 and 13 just, yeah, I agree with you. It stands out as why?
Yeah, I'll never get over it, I don't think.
You'll
But
forget about it, I'm sure of it.
probably. All right, so we'll get into our first topic here, which is a post by Project Zero that's a follow up to their post in December of 2021, covering the forced entry NSO group zero click exploit through iMessage. I don't believe we covered the first part of this blog post on the show because we went break basically right when it dropped.
So we
Um,
didn't we covered the exploit. We didn't cover the post because the
right.
exploit was covered by the I think somebody got it from Citizen 1 and then they had their own breakdown of it. We covered the exploit that was used, just not the exploit strategy, which is what Project Zero really dove into in their post, which
Yeah,
was a
you're right.
crazy exploit strategy.
It was absolutely insane. Um, to ring a bell for those who might have seen it and just forgotten about it, that was the exploit strategy where they basically wrote an entire weird machine or architecture um, based on the JBig2 format. So yeah, that blog post covered the parsing bug and the core graphics PDF parser. I believe it was an integer overflow, and they could perform like and or XOR and XNOR operations out of bounds, which NSO literally used to build NAND gates to build that architecture, which they used to exploit the sandbox escape bug we're going to talk about in this post. Um, Unlike the first bug, this vulnerability isn't so much of a memory corruption, but is rather a logic issue. Though before covering what the bug exactly is, there is some important background that's necessary to understand it. Um, so Project Zero stumbled into this when they observed that the malicious GIF file from the payload they were using was leaking memory. And when they looked into what memory was being leaked, they discovered it was JBig2 bitmap objects, which had a serialized NS keyed archiver object in it, which itself contained these NS function expression objects. So those who don't do Apple research or development in Objective-C might not be familiar with these. I certainly wasn't. I had to do some looking. But Objective-C supports these things called NS predicates, which you can use to query and filter an object, such as an array or something like that. And these predicates can be created in the form of expressions, such as NS function expressions with the function keyword to invoke an arbitrary method. So, with some messing around and some trickery, and to like nest function calls, you can, for all intents and purposes, execute arbitrary Objective C code with these function expressions. Now, the way they got this expression object to get used and evaluated was somewhat interesting because there seems to be no reason to support these types of expressions for parsing JBig2 data. But Objective C objects have this metadata field called ISA, which contains things like a pointer to an object's class and some flags and such. And importantly, this field isn't protected by pointer authentication codes prior to iOS 14.5. So with the out of bounds write scenario they had with the first bug, they could basically take an adjacent JBig2 bitmap object and smash an ISA to fake an NS function expression object, which allowed them to get the Objective C arbitrary code execution, I believe. So once they effectively have the ability to execute obfusc, that's where the sandbox escape comes into play, which involves NSXPC. That's Objective C's RPC mechanism, where you can basically proxy an object across a process and invoke method calls on your exported object to call it another process. In order to facilitate that, exported objects have to define a protocol or a policy which designates which methods can be called on it and what types are allowed for the arguments. Um, the problem here, or at least half the problem here, is that that type enforcement by design is pretty loose, because not only will that exact type be accepted by NSXPC, but it will also accept any subclasses of that type. So if you have some service that exposes an object that will take an argument of an NS object, you can effectively pass almost any object that exists because all objects in Objective C will inherit from that NS object. Like context. So yeah, just kind of a weak by design thing there, which was called out in a Project Zero post by Natalie, I think, like a year ago or something like that. I forget when exactly it was posted. So yeah, they ended up
Yeah,
finding an instance.
it is weak by design, but it does kind of come down to something that's somewhat necessary by the structure of Objective C and just the inherited nature of all the objects. Because it makes sense that, okay, you want to accept the NS or like NS row or whatever, or I think we're going to talk about PT row in particular. And so, some developer wants past that, but they have implemented like their own class on top of that. So it makes sense to want to accept like whatever class they provide in. You could always just say like they have to cast it down or whatever. Like there are maybe some ways around that. But it does seem like this probably stems from the language design itself. Like it's not a really easily fixed thing, although I have not seen what you mentioned Natalie has called out some of this, so perhaps being more aware. I last time I used Objective C was probably in like 2009, learning about some iOS, or it wasn't even iOS yet, it was just iPhone development. So it's been a while, but oh no, I feel like as a problem, like it's really systemic to or really fundamental to Objective C, so it does feel like a hard thing to fix. I haven't seen what their criticisms were though, so perhaps there is just something I'm unaware of that kind of makes it much easier to fix than I'm thinking.
Yeah, it's based on like how the interfacing works. And yeah, Objective C is just a little bit interesting with how that works. And I agree. I don't think this could easily be fixed. It's kind of something that's built into the design.
I mean,
Um,
putting pack on the ISA would help. I mean, it doesn't fix the core issue, but prevents its exploitation of it at least.
yeah. Um, so yeah, once you have like a service that exposes an object that'll take this NS object, you could try to pass objects such as predicates. Um, Now that wasn't the whole story because even though you technically can pass like an NS predicate object wherever an NS object is accepted, when it gets deserialized, the init routine will initially disable evaluation of the predicate until allow evaluation is called, which this method that they found, I think evaluate mobile subscriber identity, won't call because it's not expecting a predicate to come in there. So you can't just pass an NS predicate in and execute code in the comm center service. What's interesting though is there is another object type called PT section from prototype tools, which is used for like speech synthesis stuff. And the PT section object can contain child PT row objects in an array, which can have a condition attached to them. And those conditions have support for predicates. So the init routine for PT row will explicitly allow evaluation of conditions. So even though there's this defense in depth mitigation where predicates won't be evaluated immediately, you can kind of sidestep that by instead of passing a predicate directly, you pass a section with a PT row that has a predicate in it. And that effectively allows them to get arbitrary code execution in the comm center context, which is escaping the initial sandbox. From there, the exploit establishes a command and control server for the next stage of the attack, which is kind of the end of the line where P0 can go. I don't think they can do research past that. I'm guessing they just couldn't get any payloads that would have been sent from command and control. Um, but yeah, they point out though that the fact that this is a sandbox escape and it's a logic bug and it doesn't rely on memory corruption means that not only does it completely circumvent Apple's mitigations like pointer authentication, but it also would be version independent and probably like 100% stable because there's no undefined behavior technically going on here. It's abusing the feature set of what NS predicate provides. So very interesting exploit sandbox escape exploit chain.
Yeah, it's definitely a cool chain. Lot of background in this post too. As somebody that doesn't do any iOS stuff, plenty of background to kind of understand what's going on. Um, Objfly mentions in chat, NSXVC seems like such a big attack surface. Wonder if we'll see some more sandbox escapes like this. I have to imagine that with this coming out, there's definitely going to be some variant analysis to see if there are other places where the predicate object could be done. But this does still rely on that first, um, on that first corruption of the ISA before you can kind of get to this point. Um, and it does land them in the calm. What was it? The calm center, some service like that.
Yeah, it was the comm center service.
Yeah, so it breaks out of one sandbox, but I'm not sure. I imagine that's still landing them into the services sandbox, which is going to be more privileged being a service. But it's not getting them like completely out of the woods yet. They still need, I guess, more of escape. I guess from that point you'd probably go for a kernel target anyhow. Or no, because they do start talking about yeah, you know what, my familiarity at this level of iOS just isn't there to, I guess, comment too much. But I imagine there will be some more variant analysis, see if there are other places for this, but NSXBC just, I mean, it's the inter-process communication, so it's used everywhere. So there is a pretty big attack surface with it.
Yeah, any like RPC or IPC mechanism like this is going to be like the prime target, or a prime target at least when doing research. Since you're mentioning like variance analysis and possible of future bugs coming out of this, it's worth noting that the Apple did take some pretty big steps in mitigating this attack in iOS 15.1. Most notably, they now forbid NS expressions from performing operations with significant side effects, like creating and destroying objects. So that kind of neuters the capability of being able to execute just arbitrary code through the function expressions. And as I mentioned earlier, that ability to scribble over the RS or the ISA field um, was mitigated in 14.5 because I think it is now protected by pointer authentication codes. So there was a few steps here taken by Apple. Um, Now, of course, like for the exploit chain, there were some additional steps in the chain involved with like getting that speech synthesis library I mentioned loaded. You can look at the post if you're interested in some of those finer details. It's more just like housekeeping stuff and bridging libraries to get it loaded in the system. But yeah, I mean, overall, cool sandbox escape, but it is super intricate and requires some pretty deep knowledge of NSXPC and how Objective C objects work. So um, there's a lot of information here that might be a little hard to follow if you're not in like familiar with Objective C. It was a bit of a struggle for me for that reason.
Yeah, I mean, honestly, so many of the P0 posts can be a bit of a struggle to get through. They do a good job, I think, giving kind of the information you need.
Yeah. All right, so we'll get into our next blog post from PQL on two vulnerabilities in the Linux kernel in the NetFilter subsystem, an out-of-bounds access and a stack uninitialized use. The first of which can be full chained on its own to get root, and this can be used to exploit the latest versions of Red Hat and Ubuntu, which is pretty notable. The post goes into a good bit of background on NetFilter and NF tables or NFTs. We're going to see that acronym a lot in here. We'll mostly skip over a lot of that background, though I do recommend checking it out if the NetFilter subsystem sounds interesting to you. It's worth noting that the functionality abused here is only accessible to CapNet admin, but as we've mentioned many times before on this podcast when covering Linux issues, you can acquire this capability pretty easily with user namespaces, which seem to be enabled on like every distribution. Um, and for those not aware, user namespaces, they basically allow you to get like a fake root where you can sandbox yourself, but in exchange, you get a full set of capabilities, which vastly increases your kernel attack surface that you can hit. The purpose of NetFilter specifically is basically to facilitate like hooking and packet filtering. It's used for it has modules for things like NAT and things like that. I'm not super into networking, so I can't go too deep onto all the like modules that it supports, but that's kind of the primary purpose of it. Um, the other one of the main components that's important for this vulnerability is NF tables, which can allow users to set up rules for like packet filtering and routing and whatnot. And you communicate with it through netlink sockets with the NetFilter protocol, where you can send messages which will get parsed, and you can use those to create and manage tables, objects, and most importantly, rules. Um, Rules are comprised as expressions which are evaluated and executed. It's kind of similar to BPF if you're familiar with that. It's got its own like state machine. It has registers that are stack based, and you can pass in expressions that'll get executed. Um, so yeah, like I said, there's registers stored on the stack, and expressions can end up needing to use and parse those registers, which is done with this NFT parse register load function, which takes a register enumerator and a length for the read. And it'll try to parse and validate the register specified in the expression before using it to look it up on the stack. So this function is a pretty good target to look at for bugs because if that validation code is bugged, spoiler it is, you could obtain an out of bounds write or read on the stack, which we've seen in BPF and similar subsystems before.
Although in
It tur-
fairness, that function is also pretty small to take a look at. As a function, it's something easy to just look at and be like, okay, they're doing bounce check and move on. Um, like you say, it's a good function to look at, so I'm just calling that. Like it's also kind of small and easily overlooked.
that's true. That's fair to call out. But yeah, in this case, there was a bug in this function. So it turns out to validate function as an int overflow. Um, for those who can see the code on the screen, you can see there's like this if statement near the bottom of the function where it will take the register index, multiply it by the register size, add the length to it, and check if that's bigger than the size of the data field. The problem is the register index and the length are both unsigned integers. Actually, even if the length wasn't, this would still be a bug. So when it's doing that multiplication, it's only doing so with a 32-bit integer. There's no casting going on or anything. So that can end up overflowing and it will pass that check. But then later on, it will use the register uh, out of bound in an out of bounds
Yeah,
context.
and in
Um,
fairness, I think to the developers here, like the thought going on here is that the register, so this enum, it's a enum NFT registers read, and I imagine you were probably about to say this, but is they're expecting this to just be a single byte. So if it's just a single byte multiplied by 4 plus length, which is I guess it is unsigned integer length, although for this attack they were only able to use basically 1 byte, so I'm assuming there's another check on the length itself, along with law from just using static lengths. Um but they're expecting just 1 byte, so that wouldn't actually overflow. It's only when you kind of have the interaction here where the enum by default, or kind of like the base state of an enum, is going to be an integer, and then in some cases the compiler can optimize that down if it will fit into a smaller space, into a smaller size, but kind of the base state is to use it full integer, all 4 bytes there. Which, so it seems like the thought going on for the developers is that that's just going to be a single byte, and that's the function that actually calls this register load. I think it's somewhere in here. Yeah, right here. It's basically assigning the output value, or the register that gets back effectively. Sorry, not the output value, but it's sorry, the register it gets from parse register goes in there, and then it's doing the validation. So it ends up assigning that into just this U8. So it's thinking of it as just a byte long, even though it can actually be the full 4 bytes. So I did want to call it at least that discrepancy there, where the developers here are probably thinking about it as just that 1 byte long thing, and the fact that it can actually be, depending on compiler settings, a 4 byte value is kind of where you get the overflow to happen. There is at least a little bit of logic here, perhaps that the developers thought of, or perhaps they just didn't recognize it at all.
Yeah, so there's a lot interesting going on here, despite it being such a simple vulnerability. Um, and this kind of tripped me up a little bit as well, because integer promotion rules in C are hard. When I looked at this if statement, I was wondering, like, how is this bug even exploitable, or how is this bug even a bug? Because I'd assumed that both sides of the expression would be promoted to the maximum size between the two sides. So in this case, because the right side of the expression is using a size of, I figured the left side would implicitly be extended to a 64-bit. Now, that doesn't really matter in this case because the register multiply is where the bug is happening. Even if you casted the entire left side of the expression to a 64-bit integer, or a long technically, the multiplication will still overflow before it gets extended. Um, but there's also like a bit of an optimization happening here where that left side doesn't even get casted to a 64-bit because the compiler takes some liberties with some optimization there, which I won't go too deep into because it's not super relevant. But there's kind of the two parts. There's the multiplication that's happening there, and what Z was calling out with the enum being used. Um, the thing with enum is you don't really know what the size is going to be at the time of writing the program. The compiler kind of has some flexibility what it wants to do with it. There's not really any guarantees that are provided on the size, so that's like the root cause of the bug here. Is just don't use an enum like this. Like you should be explicit about your types and the sizes you're using. It seems like the Linux kernel that's like frowned upon because it takes too many characters on a line. I don't know. But if they used explicit types here, they probably wouldn't have had this bug. But yeah, all that background
Or at
aside,
least it
what's
would have
happened?
been more obvious.
Yeah, it would have been caught quicker probably. So yeah, all that aside, what's ultimately happening here is the integer overflow allowing you to bypass that check. From there, you could derive a few different primitives depending on the type of expression you used. For example, with the NFT payload, you could get an out of bounds write with up to hex FF bytes of data, and with the bitwise expression, you could get out of bounds read and write, but only up to hex 40 bytes. You could also influence how far out of bounds you would write with the register index provided. Um, with the math worked out, I believe your range was basically hex 30 to hex 43C out of bounds from the regs object for bitwise, and hex 304 to hex 4AB for the payload. And that regs object was hex 50 bytes on the stack, so you're getting quite a bit of out of bounds access there, which yeah obviously can be exploited. There's a pretty great diagram that shows like the state of the stack with I believe an output chain. It just helps you visualize it and keep track of things a little bit better.
Yeah, and on the
um,
note of that, actually, we'll mention that all of this is happening as like a stack-based overflow, which has at least some interesting implications. So oftentimes, like a lot of the issues we've covered end up being the heap-based overflow, where you just groom whatever object you want next to what you're overflowing and kind of go from there. On the stack kind of you're left in a position where, like, in one sense it's better because it's going to be more stable. Like, you usually have a very similar call stack. Well, not always exactly the same, but like you can get a consistent call stack and you're going to know what's there, but you also are a lot more limited. Like, you can't suddenly have your functions being called in just completely different ways necessarily. Like, what exists in the code is kind of what exists. You can't change that too much. There are ways things you change. So in this case, Spectre just mentioned like the output chain versus input chain being another one. Basically, you have, at least in that case, two different stack setups that lead to it. So he diagrams out exactly what that looks for, but I don't know, the stack's always interesting because you do have that consistency across it, but you do have a lot more limitations on what you can actually get access to. So in this case, it happens to work out where he was able to get some with that, but I'll leave the rest of that to you, Spectre.
Yeah, you get the consistency at the expense of influence.
Yeah.
I've kind of said this a lot on kernel topics, but with like the kernel heap, you get a lot of influence on it from user space compared to a lot of other different types of applications. But with the stack, like you said, you're kind of stuck with the call stack that you're able to trigger. So, uh, yeah, because you have both an out of bounds read and write, this bug on its own could be full chained because you can leak pointers on the stack either by using the side channel trick that's documented here, which is actually pretty cool. It's based on the idea that because you're doing packet filtering and you can accept and drop packets and write rules based on like the value, you can use the out of bounds read on the value to try to leak pointers by side channeling whether or not packets get dropped. There's also some other tricks you can use that more directly allow you to leak pointers off the stack, such as using dynamic sets, which are like a database you can use to read and write registers, or the payload expression itself, which apparently it can write to like the packet itself, which wasn't really known at the time that this exploit was written, but
Yeah, and
um,
honestly, like I can feel a bit for PKO, like going through this, and it's like the security maintainer is like you can use the dynamic sets to do it or whatever. Like, you spend all the time. But I've got to say, it's a great side chat, like just a great attack they went through. Kind of has the CTF feels to it, trying to leak it that way. But reading it, I just thought it was a great approach to it, regardless of whether or not there was another way of doing it. The implication here is that the dynamic set might have been easier. I don't know if that's actually the case. But yeah, I mean, I just wanted to call that out. It's like sometimes you spend time doing things that just aren't necessary, but are still kind of cool in the end. At least get a good story out of it, I guess, or type 2 fun in that sense. But yeah, I just thought the technique used here was cool, regardless.
Yeah. So since you can ultimately leak pointers and defeat KSLR, and you have a stack out of bounds right, which you can use to smash a return address, code execution is fairly easy to achieve here because the primitives are super powerful. The other bug that was detailed here was a lot simpler than the first one,
Before you
and
move
was
on, sorry,
yeah,
you
go ahead.
just jumped right into getting code execution quite easily, but you actually did have a little bit of a challenge on that, and that's because this initial thing he's using the output hook, or so just being on the output chain. Um, he's using that, and the way things align there, he would basically be able to um. So for those of you watching, you can kind of see how the structure here is the NFT payload has this reach that goes just a little bit beyond UDP send message, and just happens to right after the start of UDP send message. So the two return addresses that he can get there, he can't actually reach UDP send's return address on the stack. Can reach the inet send message, but it just happens that the alignment is that he'll write 3 bytes onto or he can basically only access the 3 bytes of it, meaning that he's going to be corrupting a little bit before that, which is your stack canary, overwriting the stack canary, and thus can't actually do the overwrite there, which meant using a different option. The input chain had a different stack layout, which I can scroll down to here, having kind of many more options on there, but also being able to target the indexing just right. So he's only overriding that, not corrupting his stack canary, and just kind of sniping the stack pointer out of the stack.
Yeah, and it's good you brought that up actually, because it kind of adds support for what you were talking about earlier with your lack of control over the stack and how you have to uh you might be stuck in a situation that kind of screws you over. So it's good in this case that you were able to get an alternative call stack and be able to exploit it. But yeah, um, that's totally like a good call out. So yeah, I'll move on to the other bug, which is a lot simpler, and it was an info leak due to the reg structure in NFT do chain being uninitialized, and that's literally it. It just wasn't initialized. So using the same sort of side channel trick already mentioned, or dynamic sets or whatever, you could leak uninitialized stack content. So yeah, that one was a lot funnier of a bug, um,
Yeah, a
and a
lot
lot
easier
simpler to
to
exploit too.
understand where it has its implications. And also shout out, he does cover guess I don't think he did covered the whole ROP chain here, but basically talked right about some of the issues he had. So return, or since he's corrupting kind of in the middle of this operation, got to leave kind of the soft RQ context and just kind of cleanly exiting and getting back to user space. Covers a little bit more on like the actual ROP chain itself in the post that I think we're not really going to dive too much into, but there is a bit more in there than what we're covering. And on the whole, like he gives a ton of background in this post. Like it's a solid write up.
Yeah, if you're not familiar with the subsystem, this post will still be accessible to you. Um, because yeah, a lot of that background is covered, and you don't really need to go outside of this post to do some digging. So
Yeah.
yeah,
Well,
that was appreciated too.
on the other side, if you are familiar, it's also a good layout for jumping exactly where you need to go just to get to the vulnerabilities if that's all you care about.
Yeah,
Because I know sometimes, we have to wade through background that we're already familiar with some articles. Sometimes we're left with not having enough information. This has plenty, but it's very easy to navigate. Just well done. I mean, and I think this is his first post, at least on this blog. So good job.
yeah, and it's worth noting there's a table of contents at the top too, so you can very easily jump around. Yeah. All right, so we'll get into our last topic here, which is a research post by Microsoft. And I'll let Z get into this one.
Yeah, and I was a little bit surprised by this one. I was expecting being Microsoft. So the actual title here is exploring a new class of kernel exploit primitive. I was expecting this to kind of be really hyper specific to the Windows kernel, and in a sense it is, at least with what they've done. But in another sense, I thought it was a really cool idea. So I actually saw this last week and wasn't going to cover it, gave it a read this week, and decided that to at least talk about here. The gist of this post is the idea of um so kind of your usual kernel gadgets we just talked about in the last exploit there, with like having a read and a write. With a read, you can kind of have the case where you can cause the kernel to read some data, but maybe not have a side channel to actually leak what that data was. And the question that they're raising here that they wanted to approach is, can you exploit a kernel read where you don't get the data back? So if you get the data back, you have a clear, just like able to break it, KASLR. You've got the information disclosure, very clear use of that. But what if you can cause the read? Can you do anything just by causing a read? And that's where they started exploring this idea of certain device drivers, peripheral devices, may have some memory mapped ranges that if you read to them might perform some other action. So they kind of posit just two imaginary devices out of this, being one that like a serial device that will basically, as you read a character, it removes it out of the buffer and just loops like that, or another device that maybe has like an atomic read and reset. So when you read it, it's going to reset the state of like a last error register, something along those lines. Just like when you read, it does something. And that devices may do this. And so, is there a way that by issuing these reads, say out of order or something like that, can you mess up that internal state logic and actually have an exploit? Fortunately, so there's a lot of background on this about how they found the ranges to try and target, and this would require you do have this vulnerability already. That's just looking at kind of dealing with that gadget. And ultimately, they discovered some ranges of interest and um, kind of tried just fuzzing those ranges by just creating threads that did random reads on it, and that they didn't have any luck. There was no attack done with this one. They didn't find an actual exploit here. But I thought the idea that, they could weaponize a read in this way just to be a really cool idea. And the level of fuzzing they did here was really basic, just literally created threads to continuously perform these reads. They did have some crashes that were basically just the drivers unmapping or remapping that virtual address space they had mapped and not actually a worthwhile crash. Um, there's a better chance that the bugs here, at least in my opinion, wouldn't actually manifest, at least not immediately with the crashes, but rather, if you did throw out the state machine a bit, you'll just have a bad state that would need to be further exploited. But I thought the idea was really cool, and I want to call this post for at least exploring that idea, something right now. I think a lot of exploits are going to have easier routes to go, but in the future, we might see something like this get exploited. I would be really interested in seeing that or seeing where people take this idea.
Yeah, this could be one of those things where you need further research on the sanitizer side of things to be able to actually detect issues that might not manifest as crashes. So, yeah, there might be some further research into that. But part of what makes this so neat is just the fact that it's starting to edge into the hardware side of things. Um, there's assumptions, or the assumptions that you would typically have when you're dealing with memory in pure software don't hold up the same way when you're talking about communication with external peripherals. When you're talking about like memory mapped IO and things like that, there's a lot of nuances there that are kind of explored a little bit in this post and are it's like the basis for what they're talking about for deriving a new primitive. So yeah, it's just I always like seeing things that talk about more of the hardware side of things and communication with it because it's an area that's fascinating to me, and there's not a lot or there's not as much public research or information documented on that side of like the kernel, the more like hardware oriented layer and communication. So yeah, I mean, this was a cool post by Microsoft. It is unfortunate they couldn't really find any exploitation routes in the drivers they looked at. I think they looked at like an Intel camera driver and like a serial I2C driver, but
It's
yeah, it's possible if they looked
unfortunate.
at more that they might have been able to find something. But like I said, I think that might just be due to like a lack of good sanitizer issue where if they had some sanitizers written to be able to measure the state of the like peripherals better, then they might have been able to find something.
I
Though
don't even know
that
if
would be
that's,
pretty tough. I don't
yeah,
even know if
like
that would be possible.
I don't know if that's really like to do that in a generic way of some that's trying to detect like state invalid states on like a particular state machine. Like that's going to be difficult to do because that's going to be device dependent. What's the state machine that this device is actually trying to do? I imagine you could do something that's targeted to a particular device and see if you can create this with a particular device, but not so much like well, I guess you might be able to write like the generic sanitizer that takes in some grammar that can then apply it. Maybe some crazy way of doing it, but I appreciate the fact that even though it wasn't like a crazy success and they found some crazy vulnerability, they've still just put the research out there for the idea to take hold. I've never thought about that as even an attack surface, so like it was eye opening for me as like there's a possibility that this could be exploited in a more useful way than just side effects for getting the information out. So like I appreciate the fact they're putting out their research, even if it wasn't insanely successful. It's still a little bit of progress, a little bit more knowledge to put out there.
Yeah, this seems like something that could be explored further, but kind of like what we were talking about with the sanitizers, it just wouldn't scale too well, I don't think. But yeah, I agree. I mean, I didn't even really think of this kind of scenario. So as a thought exercise, it's interesting to think about, but questionable how practical it's really going to be in a given exploit situation.
Yeah, I guess current exploit in chat mentions the idea is not that new, but we have yet to see real exploitable arb read. Fair. I mean, if it's not new, I wasn't familiar with it, so I at least
It's new to
called it out on
us.
that.
I
Yeah.
Yeah.
Can't always keep up with absolutely everything, but I mean, I'm sure some of us have been in that position where you do have one of these reads where you don't get the data. Like, I wish I had a way of exploiting it, so it at least appealed to me on that sense.
All right. So Z, I believe you have a shout out that you want to get into, and then we'll wrap up the show.
Yeah, just one quick shout out since we did cover one of the BlueHat talks from BlueHat Israel. And that was the security analysis of MT. That was a few weeks ago, I think, already. Videos are out now. Videos have actually been out apparently for 2 weeks. I didn't realize that. I'm a little bit late on noticing that. Usually, I don't think they're out for a few months after the conference, so it's nice to see them out already. But yeah, they're out, so you can check out the link in the show notes to that, or just look up BlueHat IL on YouTube.
Yeah, unfortunately, I haven't yet gotten the chance to check out any of the talks, though I will definitely check out some of them. But judging off of like talks from previous years that I've checked out, generally the talks at Blue Hat are pretty high quality and have some good information in them. So I would recommend at least just taking a look at what talks are there and seeing if there's any that interest you.
Yeah, I mean, at the very least, we found the security analysis of MTE one worth covering, even from just the slides. So now there's a video with it.
Yeah, true. All right, so yeah, that's everything that we have for today. So we'll wrap it up there. Thank you, everyone who tuned in. The VOD will
Actually,
be
I
up.
guess sorry
You have
to
something
just cut you
else?
off. Yeah, I just mentioned Salio's talk about forced entry stuff's really good. I guess since we just talked about forced entry on this episode, I didn't realize there was actually a Blue Hat talk also about it, but might add a little bit more context. I haven't seen it obviously, but I guess I'll just shout that one out also.
Yeah, I'm assuming this is talking about the a brief history of iMessage exploitation talk. So maybe it talks about a few different exploits, and then forced entry is kind
Okay,
of in the mix there.
I've seen that
Um,
one at least linked out a few times.
yeah, so I'll probably give that one a listen tonight, actually. But yeah, like I said, that's all we have for this episode. The VOD will be up on YouTube and Spotify and other platforms tomorrow. Feel free to join our Twitter and join our Discord to join the community. And we'll see you all next week.